On today's episode of Cornell Keynotes, we are joined by two innovators and key players in the ever-growing space technology industry here in New York State. Mason Peck and Gregory are from the New York Consortium for Space Technology, based here at Cornell University. It's a groundbreaking center, which is funded by the U.S. Department of Defense and led by Cornell. We cover all aspects of the industry. We particularly focus on technologies, opportunities, and look closely at recent growth in the private sector to help us get a handle on where things are headed. This is a fast-growing sector of the economy right now. So check out the episode notes to learn how you can get involved with the New York Consortium for Space Technology, and heads up for information on their Symposium for Space Technology, Innovation, and Development, which is going to be taking place here in Ithaca, New York on May 8th and May 9th of this year. And now, here's our conversation with Mason Peck and Greg Ray. Welcome to you both. It might surprise some of our listeners to learn that space is big business at this point in the U.S. and all around the world. Just how big is it? Mason, let's start with you.
Around the world, it's nearly $500 billion of economic activity. In the U.S., it's north of $130 billion a year. And at that rate, that's coming up on 1% of the GDP for the nation. And now 1% might seem like a small number, but remember, people, I think, often think of space as this niche area with, every now and then we send an astronaut to space, or maybe there's a science mission. There's a lot going on, and it's pervading how we live our lives. GPS, for example, locates your phone and all sorts of other things. Communications we couldn't do without space for that reason. So really, it's kind of everywhere, even though it might not be so visible.
And how about for you, Greg? How do you see things economically, and what are the opportunities in space?
Yeah, like Mason said, almost $500 billion. If you stacked up dollar coins, you'd have enough to get to the moon and back as the height of the stack. I mean, it's a lot of money globally. One of the cool things is NASA issued the Artemis Accords a few years ago. It was an initiative to set out some measures of how we could responsibly and sustainably explore space. And we've had, as of 2024, about 53 nations sign on to that. So, space on the whole is gaining tremendous momentum economically, but also in the hearts of people and in the strategies of nations.
So let's get into the economic opportunity itself. How are they making money with spacecraft?
It's a couple different things. In fact, for decades now, certainly since the late 80s, companies have made a lot of money in communications, carrying traffic for cell phones, pagers, internet in the sky, direct TV, for example, right? Mm-hmm. So video, Sirius XM radio, so digital radio. So these have always been money makers and that's been true for decades. It'll continue. Coming up now, we've got Starlink, which is SpaceX's constellation, is providing, again, internet from space for all sorts of regions all around the world. It even has, interesting geopolitical implications. So that's been very much a mainstay. What's changed in the last just really few years is the prospect of making money in space by, let's say, manufacturing things for use on the ground, or making money in space by supporting a permanent presence there. So we expect in the next couple decades for the world, and particularly the U.S., to have a permanent presence on the moon. That permanent presence requires communications, requires resupply in terms of fuel, oxygen, water, all sorts of other things, and all the infrastructure around that for transportation, communication, supply chain, logistics, all this stuff is a money maker. So going forward, I think that's where a lot of that money is. And so that's one reason why you see at the moment, I think it's 160 rocket companies that have started up in recent years. Not all of them will be successful. And
Sure.
We have seen some successes like SpaceX and Blue Origin, but that's another way in which you make money, is actually providing the space transportation to get all these other things to space.
I'm curious about two other things. Mining resources on asteroids and the moon. And there's also this other component too, the national security component.
Sure.
Tell me about what's going on in those two spaces.
National security is huge. We have adversaries around the world that are trying to understand more about what our national interests are in space, and our national security infrastructure, particularly U.S. Space Force. They are trying to counter that with new technologies. A key component of that is the ability to do space domain awareness, new technologies in Earth observation, as well as communication technologies that allow us to communicate securely, not only between assets on orbit, but between space assets and the Earth. So national security is a huge emphasis right now.
Yeah, I think it might even be national security that leads this, but certainly NASA is also interested in that mining question. You could say that all the mass, all the material we'll ever need for a permanent presence beyond Earth is already up in space. It's just in the wrong shape, right? Yeah. It's in the shape of ore on the moon, maybe liquid water from asteroids, comets, and other places. So if we think that that's our future, if we think that our future is a permanent presence, whether, again, for national security or economic or scientific reasons in space, we need to seed that with materials to build spacecraft there, build, let's say, habitats or other, even factories in space. So that's one reason to do this mining. It might be cheaper to get it from space than to bring it all the way up there, and then you run it through a 3D printer and get what you want. So it's an interesting future where that prospect of mining, probably the surface of the moon, honestly, in the near term, but maybe asteroids at some point, where that's the most economically viable approach. It wouldn't have made sense. It doesn't really make sense now. It might not have made sense 20 years ago either. But in the near future, we'll need so much to keep the economy and all the activities going that we will be turning to the moon for those resources. So companies that are going to be doing lunar mining and lunar prospecting, these may have a bright future.
We think of some of the legacy companies, the Boeings, the Lockheeds, the Northrops, et cetera. Somewhat recently, over the last couple of decades, SpaceX has become a player in this space. And you just mentioned moments ago that we're near 200 companies who are sending craft into space for various reasons. There's also a startup component to this. Any notable startups, and how do they get competitive in this space?
I mean, I'm excited by a number of startups. I think, Greg, you're excited about a number of them too.
Yeah.
One thing to say is that almost all space companies are very young right now. Sure, there's the Lockheeds, the Boeings, Northrop Grummans. They do good work, and they're still around, and they're contributing important technologies and solutions. But also in this innovation space, there are folks like Varda Space Industries. They're building the capability to manufacture things in orbit, return them to Earth, and sell them for a profit. So that could be medications, right? So the purity of protein growth that you get in space may be the motivation for that. You can create better medicine that way. Another thing that you could do maybe is create fiber optic cable. The fiber optics you could make in microgravity are much more pure and much more transmissive, and so you could lower the cost of doing that on the Earth. And even though the cable itself might be more expensive as such, you avoid the cost of the repeaters and other things. So there are companies focused on things you might not have thought of as space problems, manufacturing these materials. But there's also companies doing some really innovative, interesting stuff. Blue Origin, a company you mentioned, right? That's Jeff Bezos' company.
Yeah.
He's hoping to develop a business park in space, orbital reef, where companies can go and do the sorts of things we're talking about, or maybe even others. So providing the means for innovation is another thing that we see happening in some of these startups.
Yeah, I mean, I think touching on orbital reef is really important, because when we think about the future of space, particularly with research, the stuff we've been doing on ISS in low Earth orbit, ISS is going to be deorbiting in about 5 years, and we need a replacement. So Blue Origin, they're working on orbital reef, but we've also got VAST with Haven 1. We've got Axiom. They're going to be building some modules for the ISS. Of course, my company, my personal favorite, is Starlab. We are producing a solution as well. So really, there's some exciting facilities going to be coming online that are going to be able to not just continue the legacy of the ISS, but enable a number of new technologies and new advancements.
So ISS, the International Space Station, right? And
Sure.
What is the value proposition for Starlab?
For Starlab?
Yeah.
Well, it's going to be one of the central facilities on orbit that allow you to continue the type of research we do on ISS. But also we see it as a keystone for igniting the space economy. And what I mean by the space economy is all of the different components that are necessary to make space work. So we've got batteries, we've got computers, we've got in-space resource utilization, we've got in-space assembly and manufacturing, edge computing. I mean, I've already said that one. But there's this whole ecosystem that has to be created. And in order to do that, you have to have platforms that are there ready to receive it, but then build off of it. So,
and there's this old saying that you can't fly until it flies. The idea being
Right.
that you have to test something exhaustively to ensure it'll work in space. And so having a platform where you can actually try some of these things out before you invest a lot of money or risk human lives, it's essential, right? It's also true, though, that with this future where it may not be as expensive to send things to orbit, or where you can, in fact, make them in orbit, maybe we'll end up not worrying as much about the reliability of spacecraft. Maybe you can fix them when they break, which currently is too expensive a proposition. NASA has done that with the Hubble Space Telescope. They've said, I think it's 4 repair missions, each one of which at least $500 million. That's not a sustainable model for commercial space.
And, the cost of space is drastically reducing. I was looking the other day, when we started with the space shuttle, it was about $50,000 per kilogram. If you're into pounds, roughly divide that by half, so $25,000 per pound to get it up into space. And with the, as new companies have come online, SpaceX is the leader right now, but we've also got Firefly, we've got Rocket Lab with their Electron rocket, as well as Blue Origin with New Glenn. That cost per kilogram of upmass is what we call it, has gone from that $50,000 per kilo level. We're looking at $1,500 a kilo now, and once Starship comes online fully, they project that'll take it down to $200 to $400 a kilogram. So we're really getting to the point of having launch vehicles and facilities that can enable us to achieve some of the things that have long been the goal, that have been out of reach for us for cost and our ability to actually get the stuff up onto orbit.
And thereby making startups more competitive right out of the gate because of that low cost.
That's right. It's a lower bar to entry.
Yeah.
It's also the case that you can design an entirely different type of spacecraft if you're not worried about its reliability. I mean, you always will want to make it reliable. But at the end of the day, if you fail and need to build it again, you could maybe afford it if you're not trying to make it this exquisite spacecraft that will survive 10, 15 years without intervention. So I think that lowering the barrier to entry just on the basis of cost is one thing, but also changing the entire paradigm where we no longer have to make these extraordinarily high reliability spacecraft. That's also going to change the landscape. I think it already has. With Starship, so the Starship Super Heavy launch vehicle that's SpaceX is developing, those low rates, $200 a kilogram, maybe $100 per pound. I guess we'll do it by pounds. It's cheaper.
Sure.
But with that low cost, it's about as expensive to send something to space as to mail it across the country. If I were to FedEx a pound from, let's say, New York to LA,
Sure.
we're talking about tens to maybe $100. And so if you think about how, again, sort of supply chain logistics happen in the country and people mailing parts all over the place, that's about the same as doing it for space. So things that we do on Earth are going to be things we do in space. And I think that's kind of an exciting future where we don't have to think of space as only this niche area with exotic technologies. They could be very terrestrial, very familiar technologies. On the moon, for example, if you're going to be mining on the moon, you maybe don't develop a new extraordinary $10 billion rover with a special attachment. You just launch something made by Caterpillar, and now it functions as you would have wanted it to for mining on the Earth. So I think that's just a neat future that's enabled by lower cost launch.
So how do you see government, industry, education all interacting? What's going on now, and where is it headed?
Yeah, well, having been at Cornell, worked on the university side, and now working on the commercial side, it's been interesting in the last year for me to be able to see how these two entities interact. One of the things that I think is important to mention is that the government sits right in the middle of it right now. We've not got to the place, at least on the commercial side, where we can fund everything strictly at the commercial level. So we really need those government partnerships. So it's really important that we have advocacy for government, that our policies are space friendly, both to universities but also to the commercial side. And if we can get that moving keep it moving in the right direction, then that's going to be a big win. But when we talk about universities and industry, really they play critical roles. They're kind of two sides of the same coin. So the universities, we're looking at a foundational role. They're the ones that are identifying the fundamental problems that need to be solved that are eventually going to lead to the enablement of new innovations to get us on space and get us in space and keep us there. The other side of that coin is the industry side. We're moving at a much quicker pace than academic research in general. And industry is the driver of a lot of the actual applicable innovations that are necessary to happen. So it's this trifecta of stakeholders that are necessary at this point to keep us moving forward. I don't know. What do you think,
I
Mason?
think that's right. I mean, this distinction between academia and industry, where academia is slow and industry is fast, I think it's not wrong. But one of the things that's at stake is that when universities are conducting fundamental research, and particularly the basic research, as opposed to applied research, that basic research, it takes a while, but you need to have it. So as a company, and I'm not speaking for your company or anyone else's, but a lot of companies do invest in IR&D, so internal research and development, or IRAD, people call it. When they do so, there's always this tension between we'd like to invest in something that's going to turn into a profit really soon, because that is what they're there for. At the same time, those really foundational innovations don't necessarily lead to profit right then. But once you've got them, then you corner the market. So that's one of those ways in which universities and companies can work together. I think with a university investing some of its time and effort with maybe government sponsorship or even universities, industry sponsorship, in some hard problem. Yes, that research is open, so it's published, but working closely with a university partner, an industry can benefit from not only that innovation, but just gaining the experience, going to get exposed to how to make these things work that makes them just that much ahead of the competition. So even though we think of our research in the university context as being for everybody, the fact is when we're working closely with industry, you get a leg up. And that's, you can't really put much of a price on that because it really has to do with your future markets. So when the industry poses a problem to a university, even if it's one that a university can take on in a general way, the company does benefit. Mm-hmm. And this is partly what's going on with NYCST, if I may. So NYCST, our consortium, we are trying to bridge that relationship between industry and government. We translate the research from universities into something that's relevant to those companies. It's still fundamental research we conduct, but we can also bring industry along for that ride. And because we do testing and all sorts of other exciting stuff in our facilities, we can give those companies exposure to how to advance their technologies. Again, we wouldn't be doing it as a so-called defense service, but we do provide them access to these maybe unique facilities. A quick example is when you're trying to launch something into space, it's got to survive the vacuum environment of space, right? Well, we have a thermal vacuum chamber. So an industry who's maybe never made a space part before and doesn't have its own thermal vacuum chamber, they come to us, partner with us, and we give them access to that, and we conduct some fundamental research alongside of it, and everybody benefits. So there is a way to bridge that gap. I think it doesn't require that, for example, a university signs a non-disclosure agreement saying we will never release the results of our research. Instead, we take on problems that are of general interest.
You're speaking as a university professor.
I am.
So, as a company who is moving at the pace of our investors or different stakeholders, it's interesting you bring that up. So so we started NYST so that we could bring these different stakeholders together. Yeah. I see the benefit, direct benefit for startups. They really need to have access to the expertise at a university, the talent pool, the facilities. But I'm still trying to understand more about how mid-sized companies can take advantage of that university relationship. And so I bring that up because, the pace of innovation at a university, let's say it's years, a year to 5 years. At a company, they're looking at a quarterly pace. So they're running on parallel tracks, but at different rates. I'm excited about the consortium model, though, because it kind of forces us all to recognize and address these issues. And there's a lot of these consortiums going on right now. University of Florida has one, down in Texas they've got several, but it's really been kind of the rock tumbler that we all get into, and we're kind of rough around the edges. But after we spin around a few times, we get smooth for being with each other. So it's been really informative to me to see how that dynamic inside the consortium changes how we approach these relationships and innovation.
I thought you were playing the straight man there. I'm going to just slip you a 20 afterward, because the question you're asking, how is it that a mid-sized or even a large company could benefit from a relationship with a consortium? I think the quick answer there is a lot of these companies, as is appropriate, they're very focused on delivering for customers, right? Mm-hmm. So if they do have a thermal vacuum chamber in our example, that's 100% booked getting their hardware into space for some sponsor. And then when they want to conduct IRAD, they have no resources, no lab benches, maybe even their staff is busy doing the day-to-day stuff necessary to meet those customers' needs, as opposed to investing in the future. And that's just a natural thing that a lot of organizations do. They sacrifice the long-term for the short-term. We do this in our personal lives all the time, right? So this is a reason for us to exist and to help. We provide elasticity, if you like, in a company's desire to pursue IRAD, so that they want to do this, but they can't because they haven't got the resources or they haven't got the time. So, for example, Voyager Space, as our local example, if you have a particular technology interested in maturing, you bring it to NYCST because you haven't got your own thermal vacuum chamber because it's busy. Or your folks who would conduct the IRAD, maybe a couple of them can spare a few hours, but maybe that's just enough to provide guidance to a graduate student. Yeah. And then that graduate student can make the progress that you wish you could make. So that's just an example, but that's a way in which we actually can provide some additional acceleration to what companies do. I mean,
we need to remember that word elasticity. That is really important because I think you hit on it. Companies are focused on this quarter, responding to this request for proposal, meeting this demand of a client. And a lot of times it's an all hands on deck thing. But if we did have the elasticity to expand and contract our capability, that would be a tremendous advantage.
Yeah, companies don't dare staff up in anticipation of work they're not sure about. Mm-hmm. So almost always, a lot of organizations, I don't mean to speak for yours, but a lot of organizations are a little understaffed anyway. So this provides, again, elasticity or some other kind of schedule and capability margin that could help.
We should put that on the website. Elasticity.
Gentlemen, we did a pre-record session with John Neal, who is Executive Director of Space Policy at the U.S. Chamber of Commerce. John provides an excellent overview of where he sees the industry going in the near and long term. Again, from the government perspective, let's roll John Neal's video, please.
Hello, my name's John Neal. I am the Executive Director for Space Policy at the United States Chamber of Commerce here in Washington, D.C. I'm a native Western New Yorker, so really excited to be with you today and be with the New York Consortium for Space Technology. I've been here at the Chamber now for 2.5 years, where I work with aerospace and space companies ranging from Boeing's and Lockheed Martin's of the world down to venture-funded startups, companies that work in every sector of the space industry. It's been a really fascinating time here at the Chamber. We've seen explosive growth in the industry. Just last year, the Space Foundation reported that the global space economy is worth $570 billion. And a McKinsey report earlier this year said the space economy could be worth $1.8 trillion by 2035, which, is incredible when we think about the activity that could be going on in orbit in the next 5 to 10 years. But here at the Chamber, working with our member companies, we see a lot of hurdles that need to be still overcome in order to make those numbers a reality. Before we talk about that, let me just go back to, how are companies actually making money in the space industry? And there's a couple areas. Satellite communications. So now we are, as consumers, getting features on our smartphones that allow us to communicate in remote areas because there's more satellite communication availability to both government and consumers like ourselves. Earth observation. So, what was once the domain of agencies like the National Reconnaissance Office, we've seen a growth in companies that are putting satellites into orbit that can take pictures of the Earth every day so that farmers, oil companies, bankers and investors, FEMA, and first responders are able to use pictures that they can get on a smartphone to understand the change that's occurred in the environment that they're interested in. This capability is super important for our response to the wildfires in California or hurricane response. We're also seeing, with the transition from the International Space Station, commercial U.S. companies which are going to build space stations where astronauts will be able to travel to. You may even be able to go and spend a weekend as a tourist. And there will be an incredible amount of science conducted on these platforms due to the microgravity environment that's unique in low Earth orbit. Lastly, supply chain and components makers, manufacturers in New York State and across the country that are able to build sophisticated components for all these spacecraft that are going to be needed. There'll be a lot of opportunity there, we believe. We've seen, we think about all the proliferation and the innovation that over the past year here in the space industry. And what does that due to? All these new companies are emerging, but they still depend on government as their primary customer as they build out more and more commercial use cases. One of the things that we're working very hard on at the Chamber of Commerce is to help government move from, whether it was NASA or the Department of Defense, building their own satellites, their own spacecrafts for a government mission and government purpose, to leverage all this new commercial technology and buy it as a service like they would as software or other technologies. These commercial companies are putting a lot of money into R&D and taking that risk. Government doesn't need to do that anymore. And we're working very hard with the government to change that mentality. I also get asked a lot, how do we help our companies become more successful? From the Chamber's view, that's two things, advocating for them, both with the federal government and Congress, getting the word out about workforce needs. There's a lot of companies that need skilled labor, welders, technicians to help build the components, the spacecraft. I think testing too. What Cornell is doing to build the test beds and labs, we need more and more of that. We all know that it's very hard to operate in space. You have to have very rugged materials to deal with the radiation. They have to be able to survive for years and years in that environment. More and more testing capabilities like what Cornell is bringing online will be a huge benefit both to these commercial companies and the government as they look to rate these new systems, particularly as we take more and more humans into space for safety purposes. And then lastly, it's very exciting. I get asked a lot about what innovations are we looking at in the coming years. So to achieve our ambitions like of the Artemis program and get humans back on the moon and ultimately to Mars, we need three things: power, communications, and transportations. In communications, we see a lot of innovation around laser communications, which will allow spacecraft to communicate with each other in orbit. On the power side, nuclear. A lot of companies developing nuclear capabilities that will enable propulsion into deep space. So how can the Chamber work with the companies to get those, the regulatory approvals here in Washington to develop that technology? And then on transport, SpaceX has proven its ability to get spacecraft into orbit at a much lower cost than before, which has allowed, enable this industry to take shape. That next generation of its Starship and other companies like Blue Origin, other launch companies, getting more and more material in space will be critical. And lastly, software. I think Space 2.0 will be defined by artificial intelligence, more and more data, quantum technologies. That will be the new enabler of our next huge advancement into space.
Greg and Mason, John mentioned in the video about new spacecraft being launched. We had discussed in our pregame huddle a little bit about small spacecraft, some small enough to hold in your hand or store within a suitcase. And you had told me also that these are the most common types of spacecraft being launched.
These small spacecraft, and they can be the size of a coffee cup or maybe the microphone here, they are small enough that they're easily handled. Therefore, they're cheap to launch. In fact, you make so many of them that the way in which they interface with the launch vehicle, that is to say, the way that they're packaged, can be the same for every single one of them. That kind of template, that cookie-cutter approach to making spacecraft is very different from what was done 20, 30 years ago, where every single spacecraft was artisanal, unique, exquisite in certain ways. So these small spacecraft, sometimes they're CubeSats or nanosats they're called, or picosats. They are the most commonly launched type of spacecraft today, hundreds per year. I think approaching 500 or 600 per year. And that's across small businesses, universities, even large companies and the military. They've all found a use for these tiny platforms. One of the key innovations that they represent is quick turnaround. And there's also low stakes, right? If you have a little tiny spacecraft that costs you maybe a few $1,000s to put together, I mean, it's not cheap to you and me, I guess, but that is still much, much cheaper than typical spacecraft. So if they fail, launch another one. And that makes a big difference. How you approach the design of those is very different. But your company actually launches a large number of these things.
Yeah, we do. So we do a lot of implementation. I think what John said was really good. To get to the moon, we're going to need power, communications, transport. We know we've got to throw a lot of stuff up into space really quickly to be able to do that. But there's a lot of gaps in that technology. We need to enable technologies that are going to make up for the deficiencies that we recognize exist. So when we think about small spacecraft, we're like Mason said, the risk is much lower. So if we want to do a technology demonstration on, let's say, edge computing or a orbiting data center of multiple small satellites, right? We can send a small, a CubeSat up that has one function and it has a edge computing processor on it. It doesn't cost us a whole lot of money. And so by utilizing just a kind of a swarm approach to putting many different technologies up in orbit with the small satellites, we're able to address some of these technology enablers that are going to be necessary to build the subsystems. And then from there, the larger systems to do what John was talking about, to get to the moon and be able to do this. So, for startups in particular that are focusing on one or two technologies, there's really no better way, in my opinion, than to build a small sat, build a CubeSat, and get a government SBIR grant, test it out, and hopefully be able to transition that up to a subsystem level type technology. And I think that's, again, not to plug it. I mean, we are plugging NYCST, right? Like, we want to talk about it because it's really a game changer. But a company here in New York State can bring their small technology. They can come to NYCST in our facilities. They can build a CubeSat. They can test it. They can use the funding from the government and the expertise that they have access to at the university to get this thing on orbit and say, yes, this works. And we've got a number of companies in the consortium that do that. So
yeah, exactly. So Cornell itself has done a number of these CubeSats over the years. Again, the size of a grapefruit or something like that. But they've also been applied to other things. So there's a company called Starfish Space that has devised a means to fly a very small spacecraft up to a large one and manipulate it in some way, maybe repair something, maybe refuel it, although I'm not sure that's the priority. But there's a variety of other things you could do with these small spacecraft that are an intermediary between what we have now and what we'd like to do. But those small spacecraft can do a number of things. If the goal is just technology demonstration, that's great. They are also a means to train people. So training is a thing we do at NYCST. But it's been true now for about a decade that it's not unusual for a student in a major university in the U.S. to be able to launch their senior project. I mean, that was not true back in the Middle Ages when I was in a university, but that is true now. So students studying aerospace at any number of our top universities in the country could be designing and building a CubeSat to demonstrate some important idea, or at least get trained on that. And that's a generation of students now that's in the workforce and continually changing the workforce. The new hires that a lot of space companies get are probably students who have been involved in CubeSat projects. So it's kind of a neat future that has really only been around since about the year 2000. And so that has changed the landscape and really the complexion of what people do when they go into a space job.
I don't want to get ahead of ourselves,
Jump in
but
there.
I mean, that's just really important because, as somebody who's sitting on the commercial side, and I'm thinking about our talent acquisition and the workforce we're trying to grow, we need workforce ready people to be able to step onto the engineering floor on day one and be able to turn the bolts and do the schematics and manage the missions. And there really is no better way to do that than the hands-on type of experience that they can develop in a lab, building satellites and launching them. We move at a blistering pace in space, and we would love to have the luxury of being able to train every person that joins the company on how to do their job. But the reality is everybody needs to be able to do 10 jobs as quickly as possible And, coming out of a program like NYCST or another program at a university where they have access to the same kind of experiences is just really critical.
I think small spacecraft level that
huge.
that playing field, right? So folks without the benefit of having worked for many, many years in the space industry can go through a training program, get exposed to things like small spacecraft, and actually be way ahead of the curve, way more employable by companies looking for that kind of expertise just to get in the door. Right now, there's a significant gap in being able to hire for space companies. So it is actually one of the gaps that NYCST is trying to fill. I mean, we do some training. We'll be doing more of it. But with that training, just a nudge, so a person is familiar with at least the vocabulary, but probably also some basic ideas in how to do technician-level stuff for space, we can really elevate the capabilities of the workforce here in the region, but also help fill the gap for those folks who are having a difficult time hiring space-capable people.
One more thing,
Please.
and it's not just university level, right? We've got programs, NASA's Space Grant Program, but also NASA Hunch Program, which I don't know if you know what Hunch is, but essentially what it is, on the ISS, the International Space Station, they might have a requirement to build handles so that the crew can grab a hold of and move around the habitats. NASA actually has the Hunch Program that will equip high school students with the resources and the expertise and the training and the tools that they need to design and build these types of components. And we've got through that program a number of different technologies that have been built by high school students that are currently flying on the space station. So it's not limited to just, the higher education level. We've starting to create this ecosystem in our nation where even coming out of the high school, if you've been plugged into the right opportunity, you can step into the workforce.
The United States is gearing up for another small step or giant leap. We're going back to the moon. The Chinese have been there recently. What business do we have on the moon? There was some earlier mention of it. In addition to cislunar space, the space between Earth and the moon and right around the moon, what can we anticipate happening in that space?
There's so much going on. One thing to say is that we are entering an era where the infrastructure for space, for exploration, for science, for commerce, for military purposes, that infrastructure is a focus of technology development. We could say, for example, not just the launch vehicles, but also the ability to communicate. You may remember that movie, The Martian, where an astronaut is trapped on Mars and he cannot communicate back to Earth. That is not the future we anticipate. More likely, Mark Watney, the character in that movie, would be able to whip out a cell phone and just make a call. In fact, Nokia has been contracted by NASA to build exactly that, kind of a LunaNet type of communication system where you'd be able to use cell phone style communications to contact anything, anywhere. That network approach, that infrastructure approach is very different from the way we do communications right now for space, because right now we have a couple of big antennas. We do artisanal communications. I use that word a lot. And that type of thing works great for the occasional billion-dollar science mission. It is not a sustainable way to support thousands of spacecraft doing science or commercial activities in orbit. So communications is just one example. Being able to refuel spacecraft is another. And to refuel them, as we said earlier, we might be able to use the material on the moon, including the water. But it's more than that, too. We expect a human presence on the moon. And that's for exploration purposes. It's also because it's what we do as people. We explore. We go across that land bridge and find a new continent. That's just the way we work.
Hey, I want to zone in on the communications component. Listener JD chimes in and says, it doesn't seem that low-volume communications to remote areas or episodic imaging for resource survey or disaster recovery do not seem sufficient to sustain a large commercial space industry. Am I missing something? How will these companies make money?
There are government users, commercial users, and maybe even a few others, right? Private users, you could call them. So the government will continue to need access to communications. We see a proliferation of space assets, and those are for a wide variety of purposes, whether that's Earth observation, we didn't even talk about that, but that is a moneymaker right now, or for some other form of collecting information, call it intelligence if you like, for a wide variety of military intelligence, commercial, other purposes. All those spacecraft need infrastructure. And whether that's communications or refueling or maybe even repair parts, that is the intermediate step or the kind of infrastructure-related step that makes things possible. Let's take the example of automotive automobiles, right? So in the late 19th century, there were very few gas stations, right? There's a whole lot more because we have cars now. And auto repair shops didn't exist. There are companies who make cup holders that, serve the automotive industry. All of those kind of ancillary or sort of second or third party products, that is what we're talking about here. It's all the economic activity that surrounds the core functions of space. And again, those are things like space communications for commercial purposes, military for a wide variety of national security purposes, and also scientific. And although science was the driver for a number of decades, it is now not diminishing on its own, but in relative importance, it is somewhat diminished compared to what it was once. Mm-hmm. And we're seeing much more energy toward the commercial and the military. So those are the folks that are going to be demanding all of this infrastructure, including communication services.
Yeah. The only thing I would add to that is, as the person asked the question, how do we make money? Well, we also make money with services, right? Just like here on Earth, in order to communicate, you have to have a cell phone plan, or you have to have a subscription to your G Drive or things like that. You're going to need that in space. And the further and further we get away from the planet, we need to be able to do communications and data processing at the point of use. So there are technologies that are coming online that utilize edge computing resources that are building orbiting cloud data centers that are utilizing artificial intelligence, neuromorphic processing to be able to really provide the services that are going to be necessary for the consumer who is in space to be able to do their science, to be able to do their manufacturing, to live, to work, all those types of things. So the service industry is going to be huge for companies that can move into that space.
And so lowering the cost of access to space means more customers for space, more customers for those companies providing the services or the infrastructure materials, or whatever it might be. Mm-hmm. So I think what we're seeing is there's this strong correlation, causal correlation between the reduction in price of getting to orbit and the use of space. And that's the kind of wave we're all on right now. And unless something surprising happens that prevents that, I don't see that trend changing for a long time.
What are some of the biggest innovations in your estimation? What are things that you're excited about, that you're most jazzed about, that inspire the visionary and within all of us?
Greg is looking at me. Okay. So, well,
I just saw you get all excited and just like.
So we have 15 hours, did you say? Or
yeah, we're doing 15.
Okay. Well, look, there's so much that's possible in space and things we haven't even tapped as possibilities. So there's enabling technology where there's a specific need, sort of a pull, you could call it. And then there's other things that no one says they need yet, but it's technology that could push us toward doing something innovative. On the need side, there are very exciting science missions that are on the horizon, and we're just barely capable of doing them. One of the most exciting, in my opinion, is exploring these so-called ocean worlds. So these are the moons of gas giants, places like Enceladus, Titan, Europa, examples like that where there are water oceans in space. Probably more likely, I'm not a space scientist, but probably more likely to harbor life than Mars is. Now, we've spent a lot of effort looking for life on Mars. We found some fantastic things, and there's been some important discoveries. But if you're really looking for life, you might go where there's some warm water, and that's actually in these ocean worlds. But it's very expensive to get there, and we don't really have a lot of means to explore there. But there are possibilities, including very small spacecraft, that actually could do that. From a power system perspective, that's you mentioned something about nuclear power. That is another option. There are technologies that have been used in medical devices for years. Here, they're called beta voltaic or tritium batteries. They provide continuous nuclear power, but they have such a small amount of material that the regulatory hurdles are basically absent. And that's exciting too, because we could actually see a huge rise in exploration of parts of the solar system we've never seen before. The dark lava tunnels on the moon, or the permanently shadowed regions on the moon, where water ice might exist and where we might have people someday. I'm excited about the possibilities of exploring places we haven't explored before, and those are just on the horizon thanks to this. And I could keep going, but I'm not going to. What do you got?
You're a visionary. I'm much more of a pragmatist. So, a guy that grew up watching the space shuttle and then kind of seeing the exponential growth in the space industry over the last 20 years, I read the headlines and I get excited about it, but then my brain always goes to, well, how are we actually going to do that? So he mentioned beta voltaics. I mean, that's a really exciting technology. We're going to be able to have power on the dark side of the moon. We'll be able to use these things to heat. That's a big problem. AI how we integrate AI, machine learning, into our autonomous manufacturing capabilities. So there's companies out there like Gitai. They've got these robots that can crawl around on a space station or a satellite, and they can repair things. That's a really exciting technology. I totally geek out on the edge computing thing, but I'm very serious about it. If you want to do science, or you want to do in-space manufacturing or autonomous maneuvering, you have to have a computer that can think for itself at the point of data collection. And we're just getting to the point of having, the hardware that's small enough, light enough, but also powerful enough to be able to enable those things.
It's going to be essential when we have multiple spacecraft all inhabiting the same space, right?
Right.
So right now, and that's actually one of the areas where NYCST is focused. We're building an extremely large, full-scale spacecraft simulator where two spacecraft can move relative to each other and allow collaborators and others to evaluate how two spacecraft can work together. Once you can make two work together, you could make 10,000 work together. So that is also a path to the future here, where it's not any longer about the single Conestoga wagon that you load up and drive across the country. That's not the way that we do space anymore. Space is much more a kind of infrastructure-based, community-based setup where we all kind of depend on a bunch of other capabilities. And that first step of understanding how two spacecraft mechanically and electrically can work together is part of that. So I'm excited about technologies that will actually let that happen. And there are companies even in New York working on exactly those technologies.
I want to ask you about the grand challenges that the industry faces and the work that you want to do to meet some of those grand challenges. I'm thinking about education. How does the NYCST think about this? What are the things you want to tackle in the near and long term?
I think we have three key pillars to what we're trying to achieve. One of them we've already touched on, and that's workforce development. We know that there's a few very surgical things that we could do to elevate a number of folks who are currently underemployed or not even in the workforce and make them able to contribute to this exciting area.
What are those?
They are skill sets that include just the basics of how do you manufacture things for space, careful things you do to be sure that when you assemble a spacecraft, you're using the right materials, the right techniques. They're a little different from the everyday stuff. Testing things. So what is necessary to test a thing to make it suitable for space and the different techniques involved. And then also the care you have to have in assembling things for space. Simple things like wearing a wrist strap so that the electrostatic discharge from your clothing doesn't zap the hardware. These are things that do come up in other disciplines, but it's essential for space. So this kind of training is one of those. The other two pillars, the other is business assistance. I'll invite Greg to talk about that in a second. And the third is, of course, this shared set of facilities and capabilities so that when we build a facility like the Space Domain Awareness Simulator I was talking about, the two spacecraft, we can bring in a whole bunch of collaborators and jointly solve problems together of the type that we couldn't all solve individually. But tell us more about the business assistance thing, because that's, I think, something you've got a particular take on.
Yeah, I go back to the startups we talked about. They're trying to get things off the ground, quite literally. They want to build a technology. They want to launch into space, see if it works. That's a tremendous risk for a company that has very little operating capital. So before they get to the stage of being able to entertain potential investors, a lot of times they have to be able to show the Shark Tank that the idea that they have is actually a little bit viable. And I think that's where some of this business assistance can come in. With the NYCST, we have a large funding pool that's set aside for small businesses, or for maybe businesses are small but are looking at a particular innovation. They can come to NYCST, they can make application for that money, and then they can utilize that over a period of 6 to 8 months to really solve one particular problem that they are trying to de-risk. So it's all about buying down risk a lot of times to get one of these products to market. So, how many, we started last year, I think we made 7 awards
about that.
To local companies. We're about to do it again in May. We're going to have a symposium, and it really, we're seeing that this is really an innovative way to bring companies together to work on shared problems, but also to have a resource necessary to solve a specific problem that for them hopefully will lead to some commercial gain.
The NYCST is running a symposium on May 9th. Who is it for? What's going to take place? What are the desired outcomes for you two?
There's a couple of things that are going to be happening there. One of them is for the general public, you will learn more about space activity going on in the state of New York. So innovations, products, companies where maybe you could even get a job. There's lots of reasons that the general public might be interested in that. But for companies in particular, and our affiliated organizations, our consortium members, that will be the place where we have a Shark Tank-like pitch session for choosing the next round of funded projects, which is going to be super exciting. I'm looking forward to that. Another is we'll have some, I think, fairly compelling talks and presentations and panel discussions around the kinds of topics we're talking about here. So what are the innovations that the region, at least, and maybe even the nation needs to realize that promised future in space? So a mixture of things for everybody, right? So something for the businesses who feel like they want to actually get engaged with NYCST, and also the general public who want to engage with those businesses in some way or another. What else would you say is going to happen of interest?
I just think it's exciting for New York in general. You can probably tell I'm not a native New Yorker, but I'm super excited to be here. And when you look back over the legacy that New York has had in space, we built the lunar lander. We built glass down at Corning for the space shuttle. We've had numerous astronauts and other technologies come out of the state, and now we are coming back to a point of where companies are wanting to invest. So we had a symposium last year. We were blown away by the outpouring of support that we got and the people that showed up. We had a really small room because we didn't think anybody would come, and then it was just packed. So I'm excited to see what will happen this year. And really, I think for me, it's fun to see the momentum building for space in our state.
So May 9th, and you can check out the NYCST website, which is easily Googleable, and you'll be able to learn more about that.
Good. We're going to also share the link for membership, right, and information on the New York Consortium for Space Technologies. May 9th event that's going to be happening, the symposium on Cornell's Ithaca campus. All are welcome. Mason, Peck, Gregory, great to have you in the studio today. Thank you so much.
Thank you.
Thank you.
Thanks for listening to Cornell Keynotes. Check out the episode notes for info on NYCST's Symposium for Space Technology, Innovation, and Development, again, which is taking place here in Ithaca, New York on May 8th and May 9th of this year. I want to thank you for listening, friends, and please subscribe to stay in touch.